Good afternoon, good evening, and good morning to all of you, wherever you are. Thank you for tuning into this session. My name is Bo Liu. I am a project director at the Luskin Center for Innovation, and I lead the LCI's research program on sustainable transportation. As transportation planners and engineers strive to accommodate our travel needs in many different ways, addressing the impacts of climate change has been integrated into the planning, design, and implementation of improvements to the transportation systems. So in this session, we'll learn more about how the integration of climate and transportation planning has taken place both locally and regionally. Before I introduce the speakers, I would like to quickly acknowledge our sponsors who made this day possible, which are shown on the screen. And then to the audience, just a friendly reminder that we'll have 20 minutes for each presentation, and there will be 5 minutes for Q&A after each presentation. If you have questions for the presenters, you can ask them using the Q&A window. Without further ado, I would like to introduce our speakers. First, we have Ida Sami, who is a PhD candidate at the University of Arizona. Ida will present her work on a thermal comfort assessment in Sunlink streetcar stops in Tucson, Arizona. Ida, the floor is yours.
Hi, everyone, and welcome. My name is Ida, and I'm a PhD candidate in the University of Arizona. Today, I want to discuss about increasing heat resilience through thermal comfort assessment in Sunlink streetcar stops in Tucson, Arizona. So this is the first page. It's almost the same, so I will move to the next one. So why outdoor thermal comfort and human is important? As a definition, we are telling the heat exchange in the space determine human thermal comfort. What is thermal comfort? Thermal comfort is a condition of mind that you feel within the environment. You feel too cold or too hot. That's the comfort level. But what does thermal comfort mean? When we are talking about the thermal comfort, we want to design spaces that you feel comfortable within that space. And if you would like to learn more, you need to go to the ASHI and see the standards for the thermal comfort. I try to create a small diagram here to show you what elements play a role in a thermal comfort in outdoor spaces. There are some elements like urban street greenery, wind speed, activity, clothing that you are wearing, direct radiation, diffuse radiation, and humidity, air temperature. All of these could affect your comfort level when you are using outdoor spaces. Why thermal comfort planning is important? All of us know that extreme heat in cities can cause heat mortality and heat related illnesses such as heat stroke, heat rash, heat exhaustion, and it's mostly affecting the people in low-income communities, outdoor workers who are having existing health condition, elderly children, and can affect the climate change outcomes and increase the average temperature. So what we can do about this? If we can increase the thermal comfort planning through design and policy, we can increase the heat mitigation in cities and we can create more comfortable spaces. By this, we can also affect the public health outcome and we can encourage people to go outside and spend more time in outdoor spaces. What is the aim of this study? This paper that I am presenting right now. It's part of my PhD dissertation. We are aiming to gain a better understanding of streetcar users' thermal comfort in 5 different urban typologies: the University of Arizona, Main Gate Square, Fourth Avenue, Downtown, and Mercado. During the spring, summer, and extreme hot summer of 2021, we went out and we collect the ambient and radiant temperature in each station to get more sense of the effects of heat stress on users' thermal comfort while they are waiting for the streetcar. This research is co-produced research. So as part of my stakeholders, I have City of Tucson, PIMA Association Governance, Signing Tucson, and Shade Tucson. So during whole of the process, I talk with my stakeholders, I get in touch with them, and in every step, I ask their opinion and I ask what they are hoping to get from this project. Sorry. In this part of the project, we want to answer a question related to seasonal difference. We want to understand if seasonal difference have different effects on streetcar riders' comfort level or not. So what we did is that we went out and we did the data collection in April and July of 2021. During the spring, summer, and 1 week of the extremely hot summer. There was a week during the July that we got a heat warning awareness through City of Tucson, and that's the week that we went out. So we choose 5 different stops in 5 different neighborhoods, and we did the data collection in 2-hour interventions because it was really dangerous for us to stay outside from 8 to 6 since it was extremely hot. So this data collection took place from 12 p.m. to 2 p.m. and we started to collect the microclimate variables such as air temperature, relative humidity, wind speed, globe temperature, and we used castrol and thermometer to check the surface temperature. This is the case study map. In original work for my whole dissertation, we did the data collection for whole 23 stops, but for this specific paper, we just did the collection for 5 stops within 5 different built environments. Here you can see the picture of the stops. Each of the stops has a different built environment, different direction, and different orientation. So they have a different level of thermal comfort. How we did assess the outdoor thermal comfort? To analyze the outdoor thermal comfort, a quantitative method is used. So for calculating the outdoor thermal comfort, mainly even for the indoor thermal comfort, you need to use specific indices. For this particular project, we used the Universal Thermal Climate Index. Universal Thermal Climate Index is defined as a isothermal air temperature of the references condition that would elicit the same dynamic responses of the psychological model. Why we use UTCI? Because UTCI is one of the indices that it's calculating the closing and stop. And in past, based on my lit review paper, in the recent years, most people who are working in this area, they are using the UTCI index because it's more reliable comparing to other indices. And for calculating the UTCI, you need to have a mean radiant temperature, which we use the formula here to calculate the mean radiant temperature. In this graph, you are seeing the UTCI range. Based on the UTCI range, if the temperature is lower than 9 degrees Celsius, you will feel a little bit cold stress. And if it's more than 26, 27 degrees Celsius, you will start to feel heat stress, which is moderate, and it will get worse and worse. And when it's passing the 40 degrees, it will be very strong heat stress, which is dangerous for human health. This is the assessment that we did. I used Python to calculate the thermal comfort, and I use Python to model my data. So here you can see the name of the stops. There are 5 stops, and these numbers here is showing the UTCI value. Uh, Even during the spring time here in blue color, you will see that we are ranging in a based on the UTCI range, because it's starting from 27 degrees Celsius. So we are in the range of moderate to almost strong heat stress even during the spring, and it's getting worse and worse during the extreme heat events. You will see that it's really, there isn't any comfort level, and it's extremely heat stress, and it's very dangerous for people. So both models are showing the almost the same thing, and this is the, like, as I mentioned, during the spring here you can see that the maximum temperature for all of the stops for the UTCI is 46 degrees Celsius, which is like, it's almost close to the extreme heat stress. So based on the design and built environment and the condition that we have there, seems like we don't even have a comfortable space, especially during the 12 to 2 p.m. For stops in the spring semester. And this is showing the surface temperature for the selected.
I didn't get that. Could you try again?
Yeah, sorry. This is the surface temperature of selected streetcar stops. And each streetcar stop, as you saw in previous slides, has different materials. They use concrete, they use pavement in front of the stops, and the bench is made from iron, but it has a white coating color, and there is a warning pad or safety pad in front of each stops. We did the surface temperature measurement every 15 minutes. So then we use the mean temperature for all of the stuff, and we create this graph to show the temperature difference. The most obvious thing here is that in concrete, in shade and in sun, in both seasons and during the extreme heat, we have almost 20 degrees Celsius difference. And in the warning pad, it's based on the material that they use, it's more, and it's almost like 25 degrees Celsius difference. And since I did this whole data collection for 23 stops, and I did it from 8 to 6 for summer and spring, I know that the obvious thing is that the material that they use for the safety pad is the material that's observing the energy and sunlight during the daytime, and after 4 p.m. it's starting to release that, and it's getting cooler, so it has a bad effect on the urban heat island in those areas. As a conclusion, I should say data collection was taken using a Castrol 5400 in 5 stops between 12 and 2 p.m. in spring, summer, and extremely hot summer. In addition, surface temperature for various materials were recorded every 15 minutes in sun and shade. The UTCI index is calculated by using the air temperature, wind speed, mean radiant temperature, and relative humidity. According to the UTCI, stops are in a moderate heat range throughout the spring. There's strong to very strong heat stress during the summer, and the extreme heat stress range during the week of extreme heat weather. In a sun and shade, the most significant surface temperature difference were 21 degrees Celsius in concrete and 25 degrees Celsius in burning pad. So thank you so much for your attention and attending to this session. This is part of my PhD dissertation research. And as a part of this collaboration project, I will continue to collect surveys from streetcar users, and I will conduct an interview with my stakeholders. So I will be happy to answer any further question, and I will be happy if you email me if you have any suggestions or question. Thank you.
Thank you, Ida. I just want to open it up to the audience and see if there are any questions. So maybe I'll ask a question, Ida, just to get us started. How long do you plan to monitor this? Like, are you gonna do like a multi-year average in order to actually put out your findings, just to support your findings in a more, or are you just collecting data during just 1 year time period? Like,
the original plan was like I was planning to collect the data for 2 years, but since COVID hit and we got stuck, I couldn't get in touch with my stakeholders. So based on my PhD program, I am doing it for 1 year.
okay, I think we got a few questions from Sam. Would you like to respond directly, Ida?
Sure. But I can't see the questions. So
if you go to questions and answers at the lower right corner, I can read it out. So how do you know 20 minutes in the heat is a public health problem?
I mean, it's not 20 minutes. Based on there is a like very simple and easy guidelines through OSHA that they used. And if you are like standing there for more than almost like I think hour, but you can go and check. It's really basic based on the wet bulb glove temperature and your age and specific work that you are doing and your activity. You are in a higher risk of getting any kind of heat-related illnesses.
There is another question from Sam Blosh. Sorry if I pronounce your name incorrectly. Have your respondents told you that waiting at sun-baked bus stop has health impacts on them? If not, how do you know what the health impacts are?
Actually, currently I'm running the survey. I'm using the QR code and I am getting some survey results. But during the whole data collection, I was doing the observation. Even so, we need to have a like social distance because of COVID. But the people who were using the streetcar, always they were telling me they are suffering from heat. And I have a couple of pictures for whole my like observation that even people trying to stand in a place that has a tiny shade, and they were always asking me if I am working with the city or not. If I am working, I need to ask them to bring more shade or bring something to create more cooling, because they are like some part of the streetcar, like the stops, it's passing through the low income complex and the complex for elderly, so they are suffering from heat, and they mentioned this during my whole data collection.
So if we do not have other questions for now, maybe we can save some for later, because we do have some extra time at the end. for other questions. So maybe we can move on to our next speaker today. So next we have Montana Eck, who is a PhD candidate at the University of North Carolina at Chapel Hill. The presentation is titled "How a Changing Climate Influencing Car Crash Risk in the Carolinas." Montana, please take the floor.
Thanks so much. And as we get started, I want to thank all of you for being here today. As Bo said, I'm Montana Eck. I'm a PhD candidate at UNC Chapel Hill. I'm also a research associate for NOAA's Southeast Regional Climate Center, which is housed here at UNC as well. And my work here at the Climate Center has really been shaped around what the impacts of climate change are going to be on society, specifically looking at more of what the rural impacts are going to be. Oftentimes we think of coastal issues when it comes to climate change here in the Carolinas, but we really want to do something statewide and region-wide where we could look at the societal impacts across space and time. So just a little bit of a refresher. A lot of people, when I tell them, I do car crashes when it comes to climate change, they're a little bit confused, but car crashes are really a major concern when it comes to our changing climate. About 23% of the average 6 million annual car crashes in the US every year are connected to adverse weather, and a majority of those are attributed to rain or wet pavement in the crash reports that we have. We also know research has already shown that there's been an increase in the frequency of heavy rain events, and that those heavy rain events have led to more severe and fatal car crashes. And one thing to consider here too is that the response time to assist those in crashes has also been delayed due to heavy rain. So as we have more of these extreme and heavy precipitation events, the time to respond to them is going to decrease as well. And car crashes, no matter what, are a major concern for us because we know despite improvements to car and driver safety in recent years, car crashes still rank as the leading cause of death for age groups under 35. And being located here in North Carolina and at the Southeast Regional Climate Center, one of the things we do, we often reach out to stakeholders here in the Carolinas. And in 2018, both CERC and CISA, our sister partner, reached out to NCDOT to see what sort of climate research would be beneficial to them. And, there were some preliminary conversations, but ultimately they kind of handed us over about 15, 16 years of car crash data and said, look over this and come back to us and we'll have some more conversations. And one of the nice things in these crash reports that we have, for every single crash, we're told what the weather condition was, what the pavement condition was, if it was reported. So ultimately, the police officer, the responding officer, when it comes to these police reports, kind of has discretion into how much they fill out. They have some requirements and some that are not as stringent. So ultimately what we found is we can't really use the police report weather data to get a better picture of how weather is impacting car crashes. For example, for us, we saw over 200 accidents reported in the summer as being attributed to snow, which I don't know how many of you are familiar with North Carolina and South Carolina geography, but having snow in the summer isn't really feasible for us. And then we had about 1,000 accidents where we had a lot of confusing information. It was said that it was rainy and clear at the same time. So how do you associate that crash with a particular weather variable? So ultimately we decided, let's just not look at these. We're going to look a little bit deeper just at the crash data itself and then try and associate climate data to the crashes themselves, especially because we know North Carolina and South Carolina have some rich spatial variation when it comes to the accident patterns as well as the natural climate of the region. And one of our biggest takeaways before we met with the NCDOT and before we went back to them, we really just wanted to have an idea, when do most of our big crash days happen? So our big takeaway was our top 10 accident days in North Carolina, almost all of them had to do with winter weather and snow events. And it really didn't matter. You kind of saw a mix and mash of really heavy snow events like we see down here for the December 18th, 2009 event. Very heavy snowfall, more than a foot of snow fell in most of Western North Carolina. And then in 2015, we had very light snow, less than 2 inches, but it was pretty much across the state. But no matter how we looked at it, our heavy crash days or our higher than normal crash days really coincide with winter weather. So as we went to meet with the DOT, we really expected they're going to want something with winter weather. Let's see what we can do with winter weather for them. And that wasn't necessarily the case. And that's kind of one of my big takeaways when it comes from climate engagements and climate adaptation, especially when you're working with stakeholders, is don't assume. Our big takeaway was we went into that meeting thinking they would want us to do something with snow and winter weather for them, and we came out with something different. The DOT already knew that winter weather was a problem, but they also know that a lot of North Carolinians and South Carolinians already prepare for winter weather. It might not show that well in the crash data, but there's ultimately not much they can do other than issue advisories and put salt on the road. What they were more worried about was rainfall, and they viewed that as a consistent threat throughout the year. Snow and winter weather might only happen 3 or 4 months of the year, but rain is more of a consistent threat January through December. And it's something that people in the Carolinas don't really think about as a impeding factor on their driving. One other thing from our conversations with the NCDOT was they really wanted to understand how that these crash patterns differed in rural and urban areas, and looking at that, maybe if we can get down to the interstate level, but for what I'm talking about today, we're looking county level. And then their ultimate goal was to pinpoint where can we understand disparities or differences in crash patterns when it comes to rain events versus dry days. So we went back, we came into that thinking we were going to look at winter weather, but we went back into the data a little bit in the research, and we really wanted to understand what has been done. And what we found is a lot of analysis to date relies on relative accident risk, and I'll talk about this a little bit when it comes to my methodology. But in its simplest format, what you're doing is comparing the number of crashes for hours or days with precip and comparing it to a day with no rain. And you compare that across time, generally very close in time. So think of a Thursday at noon, you're going to try and compare it to the previous Thursday at noon. One other thing we found very interesting is that the effect of precip on crashes is actually frequently underestimated. A lot of research done to date relies on station data, which can be very sparse. You can have an accident in one county, but the closest weather station is 2 or 3 counties away. So we wanted to address that in some way. And then ultimately, we also found that rainfall may actually have a lagged effect, especially in urban areas where if you have a heavy rain event, there's kind of like a crowd reaction on an interstate where if one person slows down and comes to a stop, the person behind them will come to a stop as well. You might not get that as much on a rural or suburban roadway. Looking a little bit deeper at rainfall, about 46% of all those weather-related fatalities occur during active rainfall, and 78% of all weather-related injuries occur on wet pavement. So even in the historical literature, we found that rainfall is actually a very big factor. Now, traffic volume does decrease. So typically people might wait a little bit before they head on the road if they see that it's raining or they think it might pass. So thinking about traffic volume. And then perception of hazard risk can also influence the likelihood of an individual level driver behavior. So again, slowing down, putting your seatbelt on, turning on your flashers, all those individual level behaviors matter too. And again, just getting a little bit back into where my interest stemmed from when I came into my PhD program, I was very interested in climate impacts on rural areas. And what we found, I think a lot of people often assume that it's urban areas where you're going to have crash outcomes in a negative way. But what we actually found is that rural roadways experience about a 2.6 times higher rate of fatal crashes than those designated as urban. You also have to think about a lack of public transportation, especially here in the Carolinas, and the necessity for car usage puts folks that live in these areas on the roads for longer periods of time. And unfortunately, we've seen in social science studies and psychology studies as well that individual level safety measures are less likely to be taken on these roadways. And that unfortunately does include seatbelt usage. It's typically less used in the rural areas of the Carolinas. So overall, after we kind of dug into the literature, talked with our NCDOT partners again, we kind of came up with 3 primary questions. And the one we're going to be talking about today is primarily focused on the first one, more or less looking at the spatiotemporal patterns of precipitation-related car crash risk in the Carolinas. And through my dissertation work, we're also looking at the duration, intensity, and frequency of these events and how that influences risk. And then also looking across the rural-urban gradient. Just to tell you a little bit about the crash data, I mentioned it a minute ago, that the NCDOT provided a really rich data set for us from 2003 through 2019. We also do have 2020 data from both NCDOT and the South Carolina Department of Public Safety, who provide the South Carolina crash data. So we do have 2020 data. Unfortunately, due to COVID, there's some real big inconsistencies, and just to help with the formatting of the data and analysis, we just exclude 2020 from analysis. It's something we hope we can come back to, because we do know that a lot of these patterns we saw, especially in rural areas, actually increased. We actually saw even more death and accidents in these rural areas in 2020. One thing I will point out is these crash reports are overall pretty much the best mechanism we have for understanding crash risk. Not every crash will be captured, but nearly all of them will. Typically, to be captured in these reports, there has to be a fatality, an injury, or property damage greater than 1,000. And overall, nearly every car crash meets that third criteria. And again, as I mentioned earlier, especially with the weather conditions, there are some reporting errors. But overall, it's the richest data set we have. And because of the requirements within the data set, our crashes can be aggregated down to geographic location, county, town, individual roadway in most cases, and then the time of day as well. So as I mentioned, we really wanted to link the car crash data with some climate data rather than just use the reported weather conditions in the police reports. So what we did was we collected precipitation data that's gridded rather than individual station level. And we got that from the National Centers for Environmental Prediction, the multi-sensor precipitation estimates. It's about 4 kilometers resolution. And it does a good job of blending radar estimates and those station gauge observations. So we have a really good blending here. And that's very valuable in some of these areas where we don't have stations. The resolution of the data helps overcome some of those limitations I mentioned of station-based research. And it does really well at capturing those high rainfall events. We also pulled in some ERA interim reanalysis temperature data, because in the Carolinas, as I mentioned, there are some winter weather events. We really wanted to look at precipitation rainfall events throughout the year. So we removed any days where the temperatures averaged below 37 degrees Fahrenheit, just to remove any chance that we saw snowfall or any icy events on those days. And one last thing I'll mention, I keep tying it back into this idea of what is a rural place and how are the crash rates different between a rural and an urban area. Unfortunately, in our literature search, what we found is that there's no real great definitions for what makes a rural place when it comes to these comparisons. A lot of the research to date just simply falls on the US Census, which also unfortunately does not do a great job at describing what a rural area is. They do a great job describing urban, but then just assume everything that's not urban is rural. And we know that there's some big differences in what it means to be in a completely isolated area, semi-urban, semi-rural. There's differences here. One of my committee members, Dr. Alan Black, attempted to overcome this by looking at counties as urban or rural based on their population density, but it doesn't account for everything that we'd want to look at. And again, North Carolina, I think this surprises folks, is actually home to the second largest rural population in the United States. So being able to quantify this and look at this in a deeper level is really important for us. So what we did when it comes to defining rurality, we built off this index of relative rurality that provides a continuous multidimensional measure of rurality. It places counties on a scale that allows for designation of like suburban, peri-urban, semi-rural, isolated. It takes into account population size, density, proximity to an urban environment. So it really gets into some things that a basic census definition would not. So when we apply that to the Carolinas, just looking at this rurality scheme and, try and keep this map in mind as much as possible if you're not familiar with the geography of the Carolinas, you can really tell where our urban corridor is. Here is Charlotte, North Carolina, which is our largest city, the county of Mecklenburg. And this, the lines you see here, I put over the interstate system just so you're familiar with where the major highways are in the Carolinas as well. We have some really isolated stretches of the state, so including here in the northeastern part of North Carolina. And then we have western North Carolina here, which is more the Appalachia region. and you see similar patterns here in South Carolina, where you have a really good mix of where our urban corridors are and where our rural and more isolated stretches of the states are as well. So what we do to understand crash risk, and again, we're doing this as a relative crash risk, we do a match pair design that allows for analysis of the precipitation crash risk across unique time steps. For what I'm showing you today, we're just doing it at a daily time frame, but we can do this sub daily, so at 6 hours, or even down to the hour if we have the data available, which gets a little murky when you get down to more of those rural and isolated counties. So again, what I mentioned earlier was when we're matching a control day that occurred exactly 1 week prior to or following an identified event. So just as you can see here in this PowerPoint, say that we're looking at March 12th, we had over a ½ inch of rain that day. We're going to identify that as an event. So we're looking for a control period to compare that to. So we look back a week on March 5th, it rained a little over a ¼ inch. We won't do any comparisons on that day because it rained on both of those days. But on March 19th, it was completely dry, so we can do a comparison between those 2 days. And basically what we do is we do that sort of analysis for each county from 2003 through 2019. An odds ratio was calculated to represent the relative risk of a crash on an event day to the odds of a crash on a control day. And any values greater than 1 indicate an increased risk of crash on a precipitation day. And then ultimately we compared the relative crash risk across that rural urban spectrum we created a second ago. And now thinking back to that map, again, knowing that you're not 100% familiar with North Carolina and South Carolina's geography, you'll see the crash risk, the relative crash risk defined down here. So remember, the higher you get greater than 1, the higher your risk is. So for example, 1.37, you would have a 37% increased relative risk of experiencing a crash on a precipitation day in that county compared to a dry day. Now we see some unique spatial patterns here that if you think back to that map I showed you a second ago, actually looks relatively familiar, because if we look and I isolate the most isolated counties, so again, those most rural and isolated counties in the Carolinas, we actually have our lowest overall crash risk. So your obvious assumption must be, oh, it must be the urban areas that have the highest crash risk. When in reality, if I highlight those counties, which again, you can see the state capitals here of Raleigh and Columbia, and then our major cities, or 2 of our major cities here in Charlotte and Greenville, Spartanburg, the relative crash risk increases, but it's overall not that high. What we notice, I overlay the interstates here again, is more of these suburban and semi-rural counties where people are having to travel larger distances that we see the greatest increase in relative crash risk. And if we put that in table format, it becomes even easier to see. So again, those isolated counties, what we found is that there's actually a slightly decrease or lower relative risk on precipitation days compared to dry days. But our rural and intermediary counties, so those kind of in the middle, as well as our suburban counties, have some of those greatest increases in relative crash risk. As I mentioned earlier, it's important to consider how many of these rural and intermediary counties consist of people that are commuting great distances for work or leisure activities. Even having to just go and get groceries can be an all-day event. And again, as I mentioned, North Carolina is home to the 2nd largest rural population in the country, with those in these counties having to commute about an average 44.5 miles a day. So that's nothing to laugh at when it comes to understanding how often they're going to be exposed to a roadway and how often they're going to be at risk of experiencing a crash. So some next steps, as I mentioned, for what we were talking about today, I really focused on the county level, but we have brought this down to smaller roadway level and town level where it's possible. But really important for us is looking at duration and intensity. So investigating the differences in car crash relative to the rate and duration of the events. In the summertime, we can have really short duration, but heavy, intense thunderstorms. And in the fall and spring, we can have these multi-day precipitation events. How do crash rates and crash risks differ on those days? And then again, wanting to compare between a minor event, so thinking about these really light events where people might not even have time to react, versus our major heavy events. And then looking across important times of day, thinking about our rush hour, lunch break, weekend, weekday. There's a lot of ways that we can dig into this data and find some interesting factors in how we can understand our climate and how it's impacting our citizens here in the Carolinas. So really important to us is always applying the results of our work. I didn't talk a lot about trends in the Carolinas when it comes to the climate, but what we know is that there's no real strong trend in annual precipitation totals, but the Carolinas have experienced a significant increase in extreme rainfall events at the hourly scale and daily scale over the last 50 years. I did want to point out in 2018, North Carolina actually did set statewide records for the wettest day, month, and year. And again, a lot of people look at Hurricane Florence, if you remember back to that event being a coastal event, but most of those records were actually broken in the Appalachian Mountains. All the results from our work and analyses are obviously shared with the NCDOT and South Carolina Department of Public Safety in the hopes that they'll be able to address some of where these precipitation-related crash risk is highest. And from some of our discussions, one of the ways to overcome this might be having speed limit signs that are more variable, so they change dependent on the weather. We've seen success with that in parts of Virginia where they adapt their speed limit signs based on fog conditions. Maybe it's something we can consider doing in some of these higher risk places for precipitation events as well. And even though my time here at Carolina and at CERC is coming to an end, we hope that this precipitation data and this routine can be used for future research here in the Southeast and anywhere else. All right, I really appreciate it, everybody. Thank you.
Thank you, Montana. So maybe I'll start with a question. So in your work, have you looked into kind of like the differences between road conditions in different areas, right? I think probably the road condition might be a major factor in those like crashes, right?
Yeah, and that's one thing when we met with the South Carolina Department of Public Safety and the NCDOT, they brought up was their hope is if we can identify some of these isolated counties or rural counties that could give them motivation to go and update their data for some of these roadways. We have great information on like asphalt type, how big is the lane, how wide is the lane, what's the border of the road like in the urban areas, but it's not necessarily the case outside of there. So our hope is that we can use some of this county level data to influence them to go and look at some of their roadways and update the data.
So maybe let's see if we have any questions from the audience. Again, just a reminder, you can type in your question in the Q&A window.
I think I see Steven's question just popped up on the side there. That's actually one thing we did find is I think everyone assumes that the heavier the precipitation event, just the increase in risk, but we actually found that some of the highest numbers of increases in crashes actually occurred with those lighter precipitation events. So thinking less than 1/4 of an inch. And again, we haven't ran analysis on this part yet, but we actually found that the greatest increase in risk happens in fall when we typically have greater periods of time in between rainfall events. So you combine, factors of people aren't familiar driving on wet roads. It's typically lighter events, and there's typically a lot more buildup on the road.
Okay. Yeah, and then there's another question from Morgan. What are your recommendations for how NCDOT and SCDPS can use your results to help mitigate precipitation-related crash risks?
Yeah, and that's a great question, and that's what it ultimately comes down to, right? Is how we're going to, improve this crash risk, especially in some of these areas. And there's been discussion of education. How can we really emphasize that you have to be more careful driving on wet roads just as much as you do on snowy days? But ultimately, who are you going to reach with that? And that's why we're trying to come up with these ideas of, can we install variable speed signage more rapidly, or make it more available in some of these areas. Currently, we only have that on a couple of interstates, where as it's typically on foggy roadways here in North Carolina and Virginia. But that would be our main recommendation, is if we can figure out which roadways these are, if we can install some of these signs that adapt to the weather conditions. So if your speed limit's 70 on a sunny day, perhaps drop it down to 50 on a rainy day, something like that.
So if we do not have other questions for now, maybe we'll save some of those at the end. Let's move on to our next speaker. So last but not the least, we have Dr. Brian Yueshuai, who is a postdoctoral researcher at the UCLA Mobility Lab, which is housed in the School of Engineering. His talk is entitled Travel Behavior and Emission Analysis in the Era of Connected and Automated Vehicles. Brian, the floor is all yours.
Okay, thank you. Hello, everyone. Welcome to my presentation. My name is Brian Yueshuai, currently a postdoc scholar at the Mobility Lab at UCLA. So the topic of my presentation today is travel behavior and emission analysis in the era of CAV. So there will be 5 parts in my presentation. First, background and state of the art and practice. Then I will talk about the methodology, research findings, and conclude all my research. So first, about the CEV, connected and automated vehicles. Actually, there are 2 concepts, like connected vehicles and automated vehicles. But in practice, we usually combine them together. So we use CEV or AVs in this study. And currently, many companies like Waymo, Argo AI, they started test automated vehicles, CVs on road with or without a human driver. And also in the government side, like the state DOT, they published some regulation policies in 2016, and also many state DOTs, they start to publish their own policies to accommodate the development of the CV. So we can see that CV will be a really promising trend in the future. And talking about the studies, state of art practice or research about CV studies, people usually use activity-based model, which is one of the travel demand model to predict the use of CV of people. But current studies, the lack of CV related data or CV preference data, so they cannot actually capture the details of people's behavior. And also some study, they cannot apply to large scale scenario. So the problem of our study here is to we aim to explore the changing trend of travel demand and travel behavior of people, and also on the other side we will trying to estimate the traffic emission derived from this implementation of CV. So this study is part of our ongoing project developing planning level analysis tools for connected automated vehicle technologies and services. So the purpose of this project is to develop a decision making support testbed for the public agencies in Southern California. And the contribution of our study is first we collect people's intent to use CEV and also their activity related preferences. And then we trying to incorporate those behavior changes due to CEV into the existing activity-based model framework. And also we trying to estimate the change in VMT, vehicle miles traveled, and GHG greenhouse gas emissions across the SCAC area, 6 counties in the Southern California. So the methodology we adopt is an activity-based approach. And as you can see here, we have a synthetic population first to represent all the residents and travelers in Southern California. And then we will conduct an AV survey to collect people's intent to use CEV. And if answer is yes, then we will ask the further question about how they design how they plan to do activities during one day and also how they plan to travel. And based on the survey results, we will first split our synthetic population into AV users and CEV users and apply them to different models to predict the travel demand, combine the travel demand, and then assign them to the road and transit network. And we will adopt a iteratively approach to find the equilibrium between travel demand and travel supply. And then we estimate the traffic emission impacts. So our study here, we were trying to capture the impact of CEV from long-term to short-term. So I will introduce each part in detail later in my presentation. So about the model, our work is developed based on the SCAC, the Southern California Association of Governments, their activity-based model framework. So currently, it's a really comprehensive activity-based model to capture people's travel behavior and predict the travel demand. And it's one of the largest ABM in the world. And this model, the SCAC ABM, the original version, will capture the long-term choice to activity choice and also the related trips, travels, and also travel modes of all people's behavior. And also in our side, in our CEV side, we will try to upgrade this model to capture new features brought by CEVs. And all the model we updated here, we circled them with a red box. And as I mentioned in the methodology beginning of the methodology section, we will design a survey to collect people's intent to use CEV and also their activity-based preferences. So we designed an online stated preference survey and distributed it to collect the people's intent to use and also in the second stage about some activity-related choices. And to make sure our sample can represent the whole population, we control several attributes like household attributes and also personal attributes to make sure our samples are can represent the whole population. So about the findings of our study, first about survey results. Currently, we ask people when CEVs are available with all the benefits brought by this technology, about 54% choose to use CEV, and which is close to another survey conducted in 2017, the California Vehicle Survey, about 52% are willing to use CEV. And next, I will talk about some behavior change in people's daily travel. First, I will talk about the work arrangement, as in the activity-based model, people's daily travel are based on activity. And then all the activities we need to predict the primary activity, the house, the work or study. So first is a work activity. So with respect to the work arrangement, which has 3 choices: work duration, workplace type, and number of jobs. After CEVs are available, for CEV users, their choices become more flexible. as we can see that the choice 13 decreased a lot, and which is like have long work duration, 40 hours per week, fixed workplace, and one job, which is like the choice of most of people. But when CVs are available, people prefer more flexible choices. And another finding is about like the home work distance. As CV, like when CV are available, you don't need to drive to work, so that like it relieves the stress of driving. And also like it brings more productivity during the like commute trips. You can do whatever you want. So that in that case, CV users can accept a longer travel time, like longer commute distance. So that this result shows that like the percentage of CV users who accept like longer travel time, longer travel commute distance, more than 40 miles, increased a lot. And on average, the homework distance changed from like 60 miles to 25 miles. And next, we will talk about like the activity frequency. Also first about work activity, which is the primary activity of all the peoples. And similar with the work arrangement choice, people prefer more flexible work activities, like the alternative 3, single work, decreased a lot from 18% to like 50%. And so that like people prefer more flexible work activities, and the work activity trips increased from 20 million to 23 million. And next is like we have finished the prediction of the primary activity. Then we will go to the secondary activity. We have like in the SCAC framework, we have two non-monetary activity, the secondary activity. The first one is household maintenance, which is conducted by like several household members. And we can say that like the pattern changed a lot. And with CV available, like people prefer to do like all the household maintenance activities in a row, like the alternative 8 shows, like they conducted the grocery shopping, household errand, and escort in one trip. And also in that case, like the number of maintenance trips increased from 50 million to 60 million. And also next is the second choice in the non-monetary activity, the primary activity, the secondary activity. And also like the people also have the same trend to conduct the discretionary activity in a row, and the number of trips increased from 18 million to 20 million. And the last prediction here is a mode choice. Like with CV available, like we can expect that people's mode choice will change a lot. So our prediction shows that like with the total number of trips increased, and also when CVs are available, about 14 people shift from other like traditional transportation modes to CUVs, like personal AV or shared AV. And also like most of people shift from like HOV driver and passengers and SOV drivers. And we also like analysis the departure time distribution when CVs are available. The left side is a distribution of departure times. We can see 2 peak hours, morning peak and afternoon peak. And we can see that like after the morning peak, the number of trips increased. And if we take a look at the like increase rate, we can find out like actually the increase rate grows a lot in the nighttime after 8 p.m. and also early in the morning. This is because like when CVs are available, people are more likely to travel. So that total of trips increased, but the time schedule, like the time we have per day is limited. So that's people, in order to like assign those additional trips, people need to like push their departure time either late or earlier in the morning. But this is unrealistic results. So in our model, we're trying to like eliminate this like estimate this like more positive estimation of travel So we eliminated 50% of the maintenance and discretionary tours during nighttime to make like our prediction more realistic. And here are the like final prediction. As we can see that like actually number of household maintenance activities decreased and number of trips of discretionary trips increased a little. But in terms of VMT, the most important like indicator of the system increased about like 22%. And also we can also predict that like people's work home distance increased by 20%. So this result can give us more insights. Like even though CV is like a really advanced technology, it can bring more benefits like safety and like a reliable travel time, and also it increase the volume on the road. But this like advanced technology may not like always bring positive impact on the system, because like as you know, like transportation system might be really complex, and once you have increased the capacity of the network and the travel time decreased, and then people will decide to travel more, and which means like in turn the pressure on the transportation network will be like become worse, and then like the congestion will become worse, and also like in terms of the VMT and also emission will also increase. So when we talking about like some advanced technology, we need to like evaluate them from a systematic view so that we can like trying to capture the real impact on the system. So at last, once we have finished the system analysis, we have like trying to do some emission prediction. So we adopt the impact model, the emission factors model, developed in South California to like trying to predict the emission from transportation. And also we calculate the running exhaust emission from passenger cars about the GHG emission per zone, and the results are showing here. So we can find out actually in the suburb area in Los Angeles and also Riverside County and also San Bernardino, like the emission actually increased a lot, which means like it can be explained by like the increased commute distance, because when CVs are available, like people live in maybe suburban area are now possible to travel to LA, so that like it induce more trips in the suburban area, which lead to like heavier emission. So that next step, we may like trying to propose some policies to either control those like the increase of VMT and emissions in the suburban area to help relieve the emission, and also like we want to make sure like the congestion in the urban area will be relieved. And now let me just conclude on this study. So first we design a survey to collect people's intent to use CEV. So according to our survey, currently only half of the person in Southern California is willing to use CEV for travel, which is not as high as our expectation. So which means like people still have really high concern about like using those new technology. So in the future, if we want to promote this technology, we want to develop like deployment in large scale, we need to like prove the safety of this, like increase people's trust in this technology. And also when CEV is available in the travel behavior side, like people may accept more flexible work arrangement, people will conduct more like flexible work activities, and so that increase a lot of like work related trips. And another thing is people now can accept longer work home distance, and so that like the travel patterns, the daily travel patterns may be different from nowadays. And also we can expect more business and non-monetary trips, which means like when travel become easier with CEV, people may prefer to travel more. And also like the SOV trips are more likely to shift to CAV, which is like the trend in the mode share, the mode choice. And the total number of trips increased by 4.9% after we reduced the nighttime trips, the unrealistic nighttime trips, and the VMT increased by 22% after CAV implementation. So that which means like even though the technology is advanced enough, but in the system side, the output of the transportation system is not like positive. So that we need to like planning more like policies to accommodate this increase in VMT. And also the emission, the GHG emissions increased significantly in the suburban area. And I want to acknowledge the help from SCAG, who helped our model development, and also this research is funded by the California Statewide Transportation Research Program. And that's all my presentation. Thank you.
All right. So seems like we have quite a few comments from Gregory, and we got some questions from Stephen as well. Maybe I'll start with the questions from Stephen, and then I'll ask Brian and maybe also Montana to respond to Gregory's comment on the pay how you drive car insurance. So I'll read the questions out first. So the connected or automated vehicles are not widely available now. Is the greater likelihood based on intentions as expressed on a survey response rather than actuality?
Yeah. This is a good question. Like in our survey, we do like a stated preference survey. We just like describe a scenario to let people know when this technology are available, both like a personal owned AV and also shared AV. This means like in the future, maybe all this technology are safe enough and is widely distributed. And in that case, how you make your choice. So this is like based on the future scenario. It's not like the actuality.
So another question from Stephen, would a conclusion be that to take advantage of CAV without increasing congestion or GHG emissions, the CAV vehicles should be electric or hydrogen powered?
Yeah, that's definitely like a really important direction to solve this problem. Like currently our study predicts that like with CAV available, like travel become easier and it induce more travel demand, which means like a higher VMT and emissions. So one direction way like is to control the travel demand, like implement some like policies to reduce like congestion pricing, something like that, to like reduce the use of CAV or like the use of vehicles. And another way is to like promotion the electrification of the transportation system, which means like we can reduce, even though the VMT increased, but with the vehicles shift to electric vehicle, so that we don't need to concern about like the emission side. Yeah, that's definitely a really good direction.
So maybe I'll just quickly summarize Gregory's comments about the pay how you drive car insurance. As Gregory pointed out, there are many benefits associated with that particular type of insurance, right? You know, for example, like reducing the frequency or intensity, right, of aggressive driving behaviors, which actually reduces some of the, for example, like crash risks, right, as Montana mentioned, and also probably like there are some emissions benefits there, right, as people care more about the mileage, right, instead of just like drive as much as you can. So I'm just maybe Brian and Montana, do you have any kind of like what are your responses Any thoughts?
Yeah, I think this would be like really good way to like incentive people's travel behavior. Like that's really good. In the behavior side, we can try to like let people do more safer driving and maybe like trying to select more like sustainable travel modes, like active travel modes to like reduce the emission and also like a VMT in the other side. Yeah, that's a really good, I think really good advice for when some like agencies planning for the future, they can like definitely take this in their mind.
Okay, yeah, I think Montana may be having some technical issues, so maybe let's see. And I guess, and then for me too, yeah, I guess, yeah, like in general, kind of like my response on that would be kind of like a roadmap to sustainable transportation, right? It's not just about technology. It's not just about behaviors or like policy mechanisms, right? It's kind of like everything, right? So we have to take it into account cleaner technologies, right? And the travel behaviors, and also like technology adoption behaviors, right? And also policy, like all kinds of policy incentives, right? Mechanisms to shift every single component towards what ideally would contribute to sustainable transportation, right? While also kind of like and also in the context of both climate change mitigation and adaptation, right? So I just feel like there is quite some complexity there, and definitely I think, as you pointed out, Gregory, this is definitely something should have been discussed more often, right? I haven't done any research in this particular on this particular topic, and hopefully we'll hear more about from the audience, maybe in the future events, and in other related conferences. Hopefully we can discuss more in other occasions. So the time is now 4:43 p.m. Pacific Standard Time. So since we have a bit time left, oh, actually, I do want to give Ida a chance to respond to, before we do that, I do want to give Ida a chance to respond to Alexandra's comment or question about the kind of like your design or policy implications or recommendations out of your work.
Yeah, thank you. Actually, Alexandra, at the end, the plan is that I'm going to create a recommendation and guideline for City of Tucson so they can use part of this recommendation in their climate action plan. Also, Sunlink Tucson is planning to extend the streetcar stops and the road is extending. So I'm hoping they will use some of this recommendation, like they will consider to change maybe the materials or bring some artificial shading or anything like that to their design elements to mitigate the heat.
Okay, so probably like going back to what I originally planned for kind of like the rest of the session. I just had kind of like have a very general question for the speakers to discuss. What do you see as some future opportunities for collaboration to expand your current research? So maybe who else you would like to collaborate with, right? Where else you would like to see your research take place, right? Or even like what other topics you would be interested in exploring further, right? Based on what you're doing right now. So I know like some of us in the audience might want to reach out, right? Let's just use the time and get your thoughts out there. How about we follow the reverse order of the presentations? So we'll start with Brian and then Antana and then Ida. Okay.
Yeah, so talking about my research, my plan is to like to expand first in the like environment side. Currently, we do some like emission analysis, really preliminary emission analysis. We just calculate the emission from like the passenger car, but actually those like trucks, the logistic freight trips, they generate a lot of emission there. So like our next step, we trying to like collaborate with the researchers from the environment side to trying to estimate more accurate emissions from transportation, and which also include both like GHG emission and also like some pollution like PM 2.5, something like that. We're trying to like expand this kind of research. And another side is we can collaborate with like researchers from public policy to see what kind of policy we can implement here to either like consider the mobility and also the equity existing in the transportation system. Like for now, like people's like the accessibility among different communities actually is not it's not like evenly distributed. Some like communities, they have some equity issue existing. So we trying to like explore in this side to see what kind of like public agency can do in the like practice.
You know, I think I have a lot of interest outside of just transportation and car crashes, but that's kind of what I'm into right now. I think you also probably got from my presentation, I'm very interested in like what the societal impacts are on rural population. So I'm definitely interested in what's happening in the southeastern United States and the Carolinas specifically. But I think a lot of my work and what we do here at the Climate Center can be expanded anywhere. And I think one of the things I took away from working with NCDOT was, you know, just being able to listen and hear what other people's need rather than what you think someone will need. And I'm happy to have those conversations with anyone as I move forward, especially as I'm finishing here within the next couple of months, which, you know, I'm not 100% sure where I'm going after this, but, you know, I'm always happy to hear other research ideas related to climate and the impacts on people.
I already mentioned that this is a collaboration research, so I'm working with different stakeholders. But besides doing my PhD research, I am also an intern and junior researcher for Red Cross Climate Center. And I am working related to heat communication there in South Asia. So my passion is like, because I am generally interested in the climate action plans and whole climate change topics. But since heat, a lot of people are suffering from heat. Heat is not like flood or earthquake. You can see the difference in the environment when it's hot, but people are suffering and a lot of people are dying because of the heat. So I would like to continue my work related to extreme heat mitigation and adaptation, and would like to work especially in the, I'm planning to, this is the last year, so I would like to start a consulting job or a faculty position, so I can, in my own skill, I can fill the gap because I have a background in architectural engineering and urban planning. There is always a gap because most of us as a planner, we don't know how we can use the climate information. So it will be great to bring a bridge to this gap so we can use the climate information and the science that we have in our planning process and make cities more comfortable.
Thank you all. I think, yeah, I think we've heard a lot from all of you about your research. I hope this is informative to many of you in the audience. So I want to be respectful of everyone's time. It's now 4:51 p.m. BST. So before we conclude, if we don't have any more questions from the audience, so I guess, yeah, before we conclude the session, I'd like to quickly remind you So before we conclude the session, I'd like to quickly remind you what's coming up tomorrow. We'll have 7 more sessions tomorrow morning, and all the themes are shown on the screen. You may also find them in the agenda. Again, thanks for joining us. I hope you enjoy the rest of your day or evening. See you tomorrow.